Yo, what is up everybody? It's Issa. I'm back again with another review video, this time for ICS 32. In this video I'm just going over everything we learned this quarter. It's fairly basic, but it gets the point across. It tells you, strategies that you need to know for the test, what's going to be on the test, and then just everything we learned this quarter. So let's just hop right into the video.
So before we talk about what you need to know on the final, we're going to talk about what you need to know about the final. So what kind of questions will be on the test? Well, according to Professor Thornton, there will be 3 different kinds of questions on the test. First kind will be reading and understanding what Python code does, particularly using the techniques that we learned in class. The second type of question will be writing Python code, so we'll have to write individual functions and then modifying existing functions. And then we have why questions. And now these why questions are pretty much asking you why you are making certain kinds of design choices or why certain methods or functions work the way that they do. Keep in mind that you do not have to memorize details of individual Python libraries. Professor Thornton should include all that information on the test for us. Also, keep in mind that the exam is cumulative, so anything that we've talked about in lecture or is online on the notes is fair game for the test. So how are you supposed to prepare for the final? Well, first you should study your notes and the examples on the website. Professor Thornton's notes are very detailed and they definitely get the point across. They are quite long, but reading through it once or twice should give you a good idea of what you need. The best way to learn how to code and learn what code does is by experimenting. So just play around in Python. If you see something on this video that you don't know exactly what it does, and I maybe didn't go into depth because I'm just giving like a very basic run over of everything, just play around with it in Python, write some code, test it out, and that'll really reinforce the information. And then finally, watch this video. If you continue watching, we go over like all of the big concepts. Your goal through studying should be to discover what information you do not know well or at all and build an understanding. So first off, we'll be talking about files and exceptions. So you should know how to write a function. This is an example function that I set up. You have the def at the beginning, which denotes that you're writing a function. Then you have the name of the function, which in this case is random function. Then in the parentheses you have your parameters. It's the parameter name, then a colon, and then the type of object that the parameter is. Following that you have an arrow and then the object type that you will be returning, and then inside you will obviously have the contents of the function. So when a function is called, it is asked to do a job. Now 2 things can happen when you call a function. 1, the function will complete the job correctly and return the expected object, or 2, the function will fail and raise an exception. And an exception really just means that the function failed to complete its job. Alright, so as you can see here, we have an exception because we're trying to find the length of a number, and numbers don't have any length. So what happens when an exception is raised? A traceback will appear in the shell and will offer insight about the error that occurred. So here we have the traceback error. These are best read from the bottom up. So the tracebacks will tell you the type of exception that was raised. So here we have a type error. It is also worth noting that exceptions are objects within Python. That is important to know. And the traceback will provide a descriptive account of the problem. So object of type int has no length. So that's what ended up throwing the error. And then the line where the error occurred. So here we see line 1 in the module. And then the contents of the line, which says print len5, as you see. So now we're going to be catching exceptions. I hate myself for that. So using try statements is an effective way to determine what we want to happen when an exception occurs. So here we have the try format that we generally try to stick to. In a typical try statement, you'll have a try and a finally, but you can also have an except and an else. So with a try, the statements inside the actual try portion of this will be attempted once. If any exception is raised, control leaves the try clause immediately. So when you have except, if an exception is raised, it'll run that code that is inside. So if you successfully get through your try, the code will now go to the else. And then the finally, these statements will run no matter what happened. So here are the legal combinations. You have a try and a finally, and then you have a try, and then you can have one except. You can have as many as you want. And then you can optionally have an else and a finally. Alright, so moving on to paths and file systems. So what is a file system? File systems are software that manage how information is stored on a storage device, like a hard drive or a USB. The basic abstraction of a file system is a file, so that is the base of a file system. In computer science, a file is a container in which a sequence of bytes is stored, and bytes are interpreted differently depending on the type of file. So text files are different than image files, audio files, so that's why they have different extensions at the end. For text files, it's .txt. For image files, it could be .tiff, .gif, .png. There's a whole bunch of things. Then for audio, there's MP4, MP3, WAV, a bunch of different things. So now we're going to talk about paths. Paths have a file name, which is a piece of metadata associated with the file. File systems tend to be a hierarchy of directories with each different directory containing files and other directories. Different operating systems use different conventions for paths. So in Windows operating systems, you have the drive in the beginning, which in this case is D. Then you have backslashes and then the names of the directories and the files. But with Unix-based systems like Macs and some forms of Linux, you have forward slashes and then you have the names of the directories and the files. What do you need from the Python standard library when we in this class are dealing with paths and file systems? Well, we need a directory called pathlib, and we used it earlier this quarter in the first couple of labs. So for the basic use of this library, we can list subdirectories, we can navigate inside a directory tree, we can query path properties, and we can open a file. So here is path from the pathlib directory. Now what this does is it represents a concrete path of the computer system type. So path.exist returns whether a path points to an existing file or directory on the device you're running the program. So here's an example. So this statement is true because this is on my computer, but if we have a non-existent file, then it will return false. Continuing on with modules from the pathlib library, we have path.isFile, which tells you if a path is a file. If it is, it'll return true. If not, it'll return false. Path.isdir, which returns true if a path is a directory, and it'll be false otherwise. Path.open opens the file pointed to by the path. The mode determines if the file is readable, writable, or both. So if you want it to be readable, you do R. If you want it to be writable, you do W. And I think if you want to do both, it's RW. And then next we have path.editor, which returns what is in a directory. And then here's an example of me importing the pathlib and path. And then I'm creating a path, and I'm calling the path. And since I'm running on a Mac, it's going to be POSIX path. If it was on a Windows, it would be a Windows path. And then when I do the type, it shows that this is a path type. So I know some of you are probably asking, why are we using pathlib and not os.path? Well, os.path provides functions that manipulate strings and not path objects. And this leaves a lot of room to make mistakes in your code. I know when I started off doing the first lab, I accidentally was using os.path, and you would always have to change the path strings into path objects, and it was just a really long way of doing everything, and it led to more mistakes until I went back and fixed it from the beginning. When you are actually working with paths, you want to use the pathlib library. Alright, now it's time for everyone's favorite recursion. So what is recursion? Recursion is a tool programmers use to invoke a function to call itself. So pretty much you're just calling a function within its own function. Alright, so here we're going to go over an example of recursion. So I've set up a problem here for myself to code, and what we're going to do is we're going to recursively print my name backwards. So I'm going to start off with the definition. We're going to call it backwards, and then we're going to give it a string called s, and it's going to return a string. And then for the sake of good programming, I will tell you what it does. So it recursively, that's a difficult word, prints a string backwards. That is what we are doing. So we're going to start off with a base case. So when you're doing recursion, you need something that stops it from just repeating forever and ever. So what we're going to do is we're going to have our base case. So if our string is empty, we just want to return the string. Also, it's good to put colons after your if statements. Then we'll have our else. And then we're going to return. And then here is where the recursive call comes in. It's going to be backwards. We're going to get rid of the first letter. And then after this recursion call, we're going to also return the first letter. So this will start making the backwards string. So if we go ahead and call this outside, let's do print backwards, and we'll give it my name. and then we go ahead and run this code, you will see that it has printed my name backwards. Next up, we will be talking about networks and sockets. So we're going to start by talking about sockets. Now, sockets are objects that encapsulate and hide many underlying details of how a program connects to another program. The connection is made via the internet, and then sockets have two available streams. One stream is the input stream, which receives data from other programs in the order it was sent, and then we have the output stream, which takes data written to it and sends the info in the order written. Now, it's handy to see network connections as two streams because it is similar to what we have done with files in regards to writing and reading. And then we have clients and servers. So the program that initiates the connection is the client, and the program that responds to the client is the server. So here's some technical information that we needed to know for this class about the internet. First off is IP addresses. Similar to a telephone number, every device has its own IP address. That's what makes it unique, and that's what that's how you're able to connect to the internet. Pardon me, I'm sipping my tea. Ooh boy. Anyways, continuing on. So IP addresses help the network determine who should receive the given information. IP addresses are a sequence of 4 numbers separated by dots. So here's an example. And each number is made out of numbers in the range from 0 to 255. And then we have loopback addresses, which is the IP address of your own computer. Now, for most computers and devices out there, the loopback address is 127.0.0.1. That's for everyone. And then in addition to IP addresses, we have ports. Now, it isn't always enough to know only the IP address. This is used to connect to a certain program on a certain machine with that IP address. And then port numbers range from 0 to 65535. Now we're going to be talking about sending and receiving text via sockets. And there are 2 main difficulties in receiving bytes. 1, decoding the bytes we receive from a byte object to a string object. And then 2, finding where one line ends and another line begins. Fortunately, sockets provide the makefile module. Socket.makefile returns a file associated with a socket. Makefile also supports methods like readline and write, which make it easy to receive and send information. Alright, moving on, we have modules. So a module is a Python file with a name ending in py that contains a collection of definitions. A definition establishes names for functions, constants, or classes. So when you're using multiple modules, you're going to need to know how to import them to get code from one module into another and be able to compartmentalize all your code and be well organized. So importing a module causes the code in that module to execute. So if you have code just sitting there, it will run when you import it. And then as of right now, with what we know, modules must be in the same directory. And then we have executable modules. These are useful when importing modules because it prevents unwanted code from running. Code only runs if the home module is the one being run. And so this is, as you've seen before, the if name equals main, it'll run that code. So if you import another module and it has code in the if name equals main, that will not run. And then we have public and private definitions. Public definitions are ones that you expect other modules to need. If you're writing a definition for something and you're going to use it in a different class, it is a public definition. Here's an example of a public definition, what it looks like. And then we have private definitions, which are definitions that are only meant to be used inside one module. So if you're not sharing it with other modules, you're just intending it to be used inside one module, then it is a private definition. And as you can see, the only difference here is that there's an underscore in front of the definition name. This is done for a good reason. This lets you know whether or not something is available from a code perspective outside of a module. I'm going to show you guys an example of importing modules. So as you see in the corner, we have the powers.py module, which provides us the square and the cube functions. So what we are going to do is we're going to import this file now, and then we want to square the number 4. So I'm going to go ahead and print out that data so we can see it in the shell. And then we're going to call square by doing powers dot and then the name of the function, which is square. And then we're going to give it the number 4. And then we're going to go ahead and cube the number 5. So if I could type correctly, we'll do powers dot cube, and then we will give it the number 5. And then we'll go ahead and run this program. And as you see, We have a statement that says this runs when powers is imported or module is directly ran. And then we have the the square of 4 and the cube of 5. So now if we go to our powers.py, you'll see that up at the top there is this print statement that says this runs when powers is imported or directly. But if we go to the bottom, we have this if name equals main, and you'll see that this was not ran. And now the reason for this is this is not the main module in the program. We did not run the powers.py module, so this did not run. But if we go ahead and run the powers module real quick, you'll see that power is the main module that is printed out. So it's very important to note that when you import something, any code that is in there will run unless it is in the if name equals main statement. Alright, protocols. Protocols are a set of rules or procedures for transmitting data over a connection. The purpose of this is to make sure you're interacting with the correct program. Now in ICS 32, we deal with a request-reply type protocol. This is where lines of text are sent back and forth between the client and the server. And then every line should be terminated by a new line sequence, or what is often referred to as a carriage return. It is very important that you are familiar with the polling protocol that is on the class website. For the sake of time, I won't be going over that in the video because it is quite extensive, but you can go ahead and just pause the video, or afterwards go and check out the polling protocol and familiarize yourself with that and what it does and why it does the things it does. Alright, next on the list is classes. So classes are a blueprint for a new kind of object. So you get to create your own object with classes. These blueprints... Blueprints? What? Damn you! Alright, so next up we're talking about classes. Now, classes are a blueprint for a new kind of object. And this blueprint specifies what objects of the class can do by defining a set of methods. So here's an example. We have the string class in Python that contains methods like upper, split, and starts with. This is how we define a new class. You type class and then the name of the class. In this case, it's thing. And then inside the class, you actually write the methods and attributes that you want to give. And then we have method calls in these classes. So you can call a method in two different ways. So we have this string that says hi internet. And then we have one way that says s.split, and it'll split the word by the space. And then we have string.split, and then you give it the string and the space that you want to split it by. Now, technically, this method takes two parameters, but you can call it in either way. This is very important to know. And then we have constructing an object. So all you do is assign the object to a variable, and that will make the object. And then you pass it along any of the parameters that it takes. So X will now refer to a thing object. And then we have objects and attributes. So classes can store values and attributes directly. And then you can assign a value to an attribute using the syntax. So we have the object name and then dot attribute name, and then you give it the value you want. And then there should be a few things that you notice here. You should notice that self._name means that the name belongs to the belongs to self, or belongs to that object. And then self is the object that the method was called on. Now moving on to URLs and HTTP. URL stands for Uniform Resource Locator, and these specify what protocol should be used to download web pages, from what host should the web pages be downloaded, and what page on that machine should be downloaded. And then we're going to go through the meaning of each part. So as you see, we have an example URL on the side here. So the HTTP is denotes what protocol to use. So in this case, it's the HTTP protocol, and that's the most common one online. After that, in the green is the host. So youtube.com, in this case, is the host. And then after that, it specifies what web page you would like to download. So in this case, it'll bring up videos from the channels that I subscribe to, since we're looking at the subscriptions. The main thing we use when dealing with URLs in HTTP is the urllib.request module. Now, this has one function that we really need, which is URL open, and that requests information from the URL that you give it. So this returns an HTTP response object, which allows us to use a read method on it. And then read retrieves all the content and returns a byte object. And then we have decode, which changes the bytes into a usable object. And then we can use split lines, which splits a string into lines and automatically handles differences in the lines ending between operating systems. Right, so following that, we have web APIs. So we have URLs with query parameters. So here's an example URL, and if you look closely, what is parameter 2?
John C.
I'm sorry. I just got to make sure you guys are awake and you're paying attention. So, you're welcome. So anyways, we have question mark is a special character when it comes to URLs. The question mark indicates that the following characters are a query of parameters. The ampersand is a special character as well that separates parameters, and then equal sign is also a special character that separates the parameter name and value. And then we have URL encoding. So special characters are translated when encoding. So pluses replace spaces, and then other characters are replaced with a percent sign in a hexadecimal character code. So an example of this is a question mark will be translated into a percent sign and then 3F. And then we have JavaScript object notation. So here's an example of a JSON. We have the name, ISA, age, 18, classes. It's essentially a dictionary. And then the URL lib parse library contains URL encode, which we need to use. So urllib.parse.url encode takes a list of tuples and returns a string that is in the correct encode format, which automatically, I believe, is UTF-8. Lastly, we need to issue an HTTP request and response. So when interacting with APIs, we want to request the JSON from the website and get the information from there. So we're going to use urllib.parse.urlopen, give it the URL to make a request, and then we get a response by using the read on that object that urlopen returns. And then we have to parse the JSON response. So you do that by using json.load. So you have to import JSON and then json.loads and give it the JSON object. This turns a JSON string into a Python object, and you can actually give it a Python object and it will turn it into a JSON string. Duck typing and interfaces. So, in duck typing, an object's suitability is determined by certain methods and properties. The idea is that it doesn't actually matter what type my data is, just whether or not I can do what I want with it. How does this affect the way we write functions? So you can write more functions and methods that are more flexible than before. You can write multiple classes and intentionally give them the same interface. And Python will automatically call the appropriate version of the method. So you can write more than one version of a method, but one will take ints and one will take strings, and Python is smart enough to figure out which one to use. So I do understand that duck typing is a little hard to explain just by putting some words on a PowerPoint. So here is an example of duck typing that is practical. So here is the duck typing module from the class website. So here at the top it imports math, and then it has a bunch of classes. So zero calc, square calc, cube calc, length calc, square root calc, and multiply by calc. And all these just have the same function inside, which is calculate, 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 calculate. This has an init method, which takes the multiplier and sets that, and then uses that in the calculate function. And then here we have another function called run calcs, which takes in a list of all these calcs that we have here, and then a starting value, so a number that you want to calculate. So the current value equals the starting value, which is the given number. So okay, so the current value is the starting value, which is the given number here, and then you do for calc in calcs. Current value equals calc.calculate current value. So what this does is it goes through each of the calculators that you have in that list, and Python intelligently seeks out which of these is the correct one, and then calculates giving the given value, and then it returns the current value. And then we have some print statements down here that run calcs and then does some calculations. So we'll go ahead and run this code. So the reason we're getting 256 here is we have square calc, and then we have 4. So square calc once will give us 16, and then a square calc again will give us 16, and then those multiplied are 256. Then we have length calc, and then multiplied by calc 2. So we have boo length count is 3, and then multiply by calc. So we're multiplying that by 2, which gives us 6. Then we have run calc, which is an empty list, and then 80, so that's just going to return 80. And then we have multiply calc, then length calc, and then square calc, so boo. So boo and multiply by calc will give us boo times 3, then length calc will give us 9, and then square calc will give us 81, which is how we get that desired answer. So I hope this makes more sense to you now that you can kind of see the code and understand what's happening. Planet, we have 2-dimensional lists. So this has a lot to do with references. So referencing spots in memory, and then referencing spots in lists. So a variable contains a reference, not an object. So when you assign an object to a variable in Python, the actual object isn't stored. A reference to the object is stored. And then you can get the value of the reference by calling the ID function. So here I made a string x that says don't fail the final, because you guys are all going to pass. And then when you call ID on that, that is the actual ID for the location in memory. So along with references comes mutability and immutability. Immutable types are those whose object cannot be changed. For example, integer values. When you add 1 to y, you don't change the value of y, you're actually creating a new integer value. And now y is looking to a different point in memory. And then you have mutable types, which can be changed. For example, lists are mutable. So when you create a list, the list is changed, a new list is not built. So as you see here, we have a list, we call the ID, and when you append something to the list and call the ID again, the ID doesn't change, it actually stays the same. So the ID has not changed at all. On the screen, there is a 2-dimensional list problem. Now, what we want to do is we want to increase each item in the list by 1. So as you see, we have a list here that is made out of smaller lists. So we have 1, 2, 3, 4, 5, 6, 7, 8, all divided into groups of 2 into separate lists. So we're going to go ahead and print that, and this code should change each value by 1, right? But you'll be surprised to find that that isn't quite the case. So when we print it the first time, it hasn't been changed. When we print it the second time, it should have been changed, but it wasn't. Now the problem with this code here is it doesn't reference the actual objects in the list. It references the place in the list that they are. So for L, it is the list, and then so we have 4L in 2D. So this is the list in 2D. It grabs the value of the list. It does not grab that actual list. And then for the num in L, that grabs the first num and then the second num, but it doesn't grab the actual object. It grabs it doesn't grab the actual object in the list. It grabs a copy of the object essentially. And then we're adding 1 to num, which is here. And then when we print it again, it obviously isn't changed. So let's just go ahead and get rid of this code and write some code that actually works. So we want to find the index of each object in the list and then change the actual object in that index. So to do this, we're going to do range. We're going to use the range function. So it's going to be 4L in range, and then we're going to do the length of 2D, which is our list. And then we're going to go again, and then we're going to do 4num in range, and then it's going to be 2D, and then it's going to be L. So it's going to be the list in 2D. Is that correct? It has to be the length of 2B. So go ahead and add extra parentheses there, colon, and then so then we're going to call 2D again. So this is calling the actual list, and then we're going to do the point. So the list in 2D, and then for the num in that list. And then that's going to be plus equals 1 since we want to increase each object by 1. And so after this, let me go ahead and print 2D. Run this one more time. You'll see that each object in the list has been increased by 1. So make sure when you are indexing and you want to change values in a 2-dimensional list that you are grabbing the index of each object and then referencing the list itself and changing it from there. And then, what's better than recursion? What's better than 2-dimensional list? Tkinter, everyone's favorite thing on the planet. So we're going to go over just some of the Tkinter basics. Then I'm going to give an example of Tkinter. So creating an empty GUI window. So in order to make an empty window, you have to import Tkinter, and then the window is tkinter.tk. Again, what? Microsoft, why do you hate me? No, it's my GUI. See, even PowerPoint doesn't like Tkinter. But anyways, continue on. Where were we? Creating a GUI window. Okay, so the window is, to make it, you call tkinter.tk, which creates the window, and then you call main loop, which actually executes the window. So when main loop is called, the Python interpreter blocks, which means all the code that you have following the window.mainloop pauses, and it waits until the window is closed or a action is called in the window. So this shows that Tkinter-based GUIs are built using event-based programming. So let's talk event-based programming. So you make a GUI active by calling the actual GUI and creating the window. Now the user effectively tells the program what events to run by interacting with that window. So if you noticed when you were doing Othello, when you made your window and it appeared and the game was going, you could click on the window and code would run, but anything that you put after, so if you put a print statement after your main loop, the print statement wouldn't run until the window was closed. There are two important things to know. So unlike previously written programs, you do not control the flow in the program. The GUI, I have the GUI twice. Just ignore that. I'm too lazy to go back and edit it. But the GUI establishes a set of event handlers, and code is inactive until an event handler is called. And then if we write event handling functions that ran for a long time, the entire GUI will be inactive until it finishes. So one action has to finish in order for another action to be called in the GUI window. So if you click on the window and a long process is going on, it'll wait until it's done before you can click again and do another process. As you know, there are widgets and options. So Tkinter windows contain a collection of building blocks called widgets. These include buttons, labels, fields. So each widget has a set of options, and here is an example of a label that I had in my Othello program. This was in the settings window before the game started, where the user determined what settings they wanted to use for the game, and this is the label that says, like, who wants to go first. So as you can see, there's master, there's text, and there's font. There's also a ton of other options. And then you have the actual layout out the window. So there are three different types of layouts. Yeah, English is good. You have pack, which puts everything in the window in the order pack. Grid, which is what I prefer to use, allows the programmer to specify where to place the widgets in the window. So you can do columns, you can do rows, and there's a plethora of other attributes that go along with grid. And then there's place, which allows you to explicitly set the position of the size of window. Now, generally, we won't use place. It's very finicky, and it's very, very exact. So here's an example from my Othello program of me gridding the label, and you have to grid the label in order for it to show up, otherwise it won't be in the window. And then finally we have event binding. So binding an event to some widget is done by calling bind. The first parameter in bind is a description of the event that you are interested in, and then the second parameter is the event handler function. So here's an example from my Othello. And then we have object-oriented Tkinter. So Canvas provides the ability to do programmatic drawing of shapes, and that's where we're going to hop into desktop mode right now and go over drawing shapes in Tkinter, and we're going to go over fractional coordinates, which will most likely be on the test. Alright, so here's an example that I have set up for behaviors and events. So what we're doing is we're setting up a Tkinter window, we're adding a button, and we're actually also adding a canvas, and well, tense is important, and add a canvas. So I have a class here called test, and then inside is an init method that takes self. So we're gonna create a window that belongs to the test class, and then we're gonna give it a button, and that button will say click for secret message, and then the command is self.click button. And so when this button is clicked, it'll go down here to click button, and it will print secret to the console over here. And then we're going to go ahead and just pack that into our window. In addition, we also made a canvas with a width of 500, a height of 500, and then the background color is this lovely, lovely shade of highlighter green that I just randomly typed and figured out. And we went ahead and packed that canvas. And then I also went ahead and binded a method to the button 1, which is the left click button, which is what we generally use to just click around. So when you click on the canvas, since this is binded to the canvas, and you left click, it will go ahead and run this code down here. And what it does is it creates a rectangle wherever you click. And these rectangles are, in fact, white. And then we're going to go ahead and run the window, and then after we run the window, we'll print that the window has closed to the console. So we have our if name equals main, which creates a window, and we're going to go ahead and run that real fast. As you see, here's our lovely canvas, and with our secret message. Now, we don't know what it is, so if we go ahead and click, we will get the secret message, which is go see Deadpool. Great movie, very funny, very good. And then you see, if we click on the canvas, it will create boxes for us wherever we click, no matter what. And then if we go ahead and close the window, it'll say the window has closed. So notice that even though this code is here, it doesn't run until the window is closed, because when you call main loop, it blocks this init code. Alright, and then the last thing we will be talking about in this video is fractional coordinates. Now, this will most likely be on the final. I'm not 100% sure. But this does seem like something that we should know, and that should be on the final. And what this really helps us with is redrawing things on a canvas when the window is resized. So I've set up a bunch of stuff here. I have my if name equals main at the bottom to test. And then I have my test class. So let's just go through each of these code snippets one at a time, and so you can kind of build an understanding of what this code is doing. So here we're establishing the window, and then below this we're establishing the canvas that belongs to that window. We're giving it a nice gray background. Then we are gridding it, and before we packed, now we're gridding it, and we're doing row 0, column 0, and then we're doing sticky to each side. So what that does is when you resize the window, it will stick to all the sides. And then we have self.window row configure and column configure, and we're giving it a weight of 1, and that's what actually allows the canvas to grow and shrink as you move the window. And then we're binding 2 buttons. So button is the left click button, and that will run this left click code. So if we go down to left click, what it does is it takes the X and Y of the pixel of where you clicked, and then it turns it into a fraction. So this is where the fractional stuff comes in. If you want to get the X coordinate, you take the X pixel and you divide that by the window width, and that will get you the fractional coordinate. You can think of the canvas as having a definite length, right? So if we want to put it into fractions, the top left corner will be 0, 0, and then the bottom right corner will be 1, 1. And then in between there are a bunch of different fractions, and no matter how big or small you make it, those fractions stay the same, but their position changes. Whereas the pixels no matter what happens, the pixels stay the same, but the position does not change. So this is why we have to do the fractions. So we get the X fraction and then the Y fraction, and when you're getting the Y coordinate, you want to take the Y pixel and divide it by the window height. And then we're going to go ahead and append this to a list as a tuple, and then we're going to call draw squares. So it'll actually end up drawing that square. And what draw squares does is it takes the fraction that you have and converts it back into a pixel with the current canvas size. And then it does that for the X coordinate and the Y coordinate, and then it goes ahead and draws a rectangle. Now, these rectangles, they won't change, the size of the rectangles won't change, but the position of the rectangles will change along with the window when you go ahead and resize it. And then we have the back up top, we have self._canvas.bind, and then we're binding the configure. So that's the command for when you're changing the size of the window. So when you change the size of the window, the resize method will be called on the on itself on the test class. And then so what this is going to do is it's going to delete everything that's on the current screen, and then it's going to go ahead and redraw everything. And then we have the self.square list. So this is how it knows what to draw when you resize the window. And then we have the main loop, which goes ahead and opens the window and runs the entire program. So if we go ahead and run this real quick, I can show you that this does in fact work. So here is our gray window. When I go ahead and click on the corner here and resize it, you'll see that everything sticks, the canvas sticks to the sides. And then if we go ahead and click, we can start drawing our squares all over the place. So far this is all looking correct. And then if we go ahead and move it around, you see that the squares, their position does change. Now I can show you what happens if we don't use fractional coordinates. So if we just set this here equal to y, and we set this equal to x, which is kind of pointless, you're just renaming it. And then if we go ahead and just get rid of this here, and we get rid of this here, we go ahead and run the program one more time, you'll see that when we make it make the squares and then we go ahead and resize, the squares do not move. So that is where fractional coordinates come in handy. I mean, of course, if this is what you want, then this is correct, but in the case of this class, oftentimes we're going to want windows to resize. So you know how fractional coordinates work and understand the math behind it, because we will most likely have to do some simple calculations on the test.
Alright guys, thanks for watching the video. I hope you enjoyed it, and I hope it really helped you guys out. If you have any questions or suggestions for anything, go ahead and leave that in the comments down below. As always, good luck on the test. You guys are going to do great. I believe that if you attended all the classes, you did all the labs, and you tried your hardest throughout the quarter, you are more than capable of passing this final. So yeah, good luck, and I will see you guys in the next video.